Good evening. We have today, this is lecture number 1, and we are with this problem. We are interested to design the baton system. Now, we have first go for given steps. So, if we will go through this problem, so we have this as built up column. So, step 1, given data. Given data. So we have two ISMC 350 at 413 Newton per meter. Then as spacing between channels is 220 millimeters. Gauge distance is given G, which is 50 millimeter. Lambda is given of whole section, which is 80. And P is given 1400 kilometers. So we have given this. Then we have step 2. We have design of battens. So clause number 7.7, page 50. So C upon RYY less than or equal to 0.7 into lambda, which is 0.7 into 80, that is 56. And it should be again less than 50. What is C? So if we will draw the diagram, so we have this as one channel. We have channel back to back. This is another channel. And we have battens. So we have in this fashion. So we have another batten. And C is center to center distance between the battens. So this is C. Now we know value of RYY for this is, so we are actually in given data, we can write that also properties. RYY is required 28.3. And we have CYY, which is 24.4 millimeters. These two data required, G already we have mentioned. So now we have C upon RYY is 28.3, and that is equal to 50. And from this we will get C equal to 1415 millimeters. So we will provide lesser than that. So I will say this is A part. That is A part. Spacing of battens. Spacing of battens. Then from this we will get, provide C equal to 1400 millimeters. Now we have B, size of batten. So this spacing of batten, actually we have clause number 7.7.3, page 51. Now we have second, size of batten. So we have, this will be intermediate batten, end batten, size of end battens. So we have clause number 7.7.2.3, We have page 50 and 51. So I will not write page every time. So depth of end batten should be greater than or equal to S plus 2 CYY. That is S plus, or we can say it should be greater than distance of centroid. So we have this distance, which is S plus 2 CYY. And then from this we will get, therefore, DE equal to S is given to 20 plus 2 into 24.4. And it comes 268.8 millimeters. Therefore, we will have overall depth of end batten equal to D plus D dash. D dash we will say effective cover. Let us, we will consider it as 40 effective cover, or we can say end distance. So this distance, end distance. And this generally we will take 1.5 DH. So is for 20 millimeter diameter, we will take it as 40 millimeter, and it comes 308.1 millimeters. Then we have width of battens. So we have width of battens. And we have this distance 100. So we have this as 100. So we cannot go beyond this. That is S plus 2B. B is width of each channel. And then we will keep some less of this. And let us, we have 220 plus 2 into 90. So 180, 200, 200, 400 mm. Then we have thickness of end batten. This is 1 by 50 into distance between centroid of bolt group. So 220 plus 2 into 50, 50 G. So we have, this is actually S plus 2G, and CYY actually we have, I will change the color. CYY we have, that is centroid. CYY is always less than G. And then actually we have this as C plus S plus 2 CYY, which we require for this. S plus 2 CYY. Values we have taken correct, but we have to show, and this is S plus 2G, which is 220 plus 2 into 50 and divided by 50, and we will get this value that is equal to 6.4 millimeters. And therefore provide end batten, therefore provide end battens as 400 by 310 by 8 millimeters. Then we have C part, size of intermediate batten. Size of intermediate batten. Same clause we have. Intermediate batten. Clause 7.7.2.3, same. And we have D intermediate should be greater than, we have this as 268.8, greater than depth of end batten, which is, here we have D of end batten 268.8. So we have this is equal to DI should be greater than or equal to 3/4 of this value. And therefore we have 3/4 of 268.8, which is equal to 201.6 millimeters. And here remaining things we have same, only depth will be changed. So provide intermediate batten as intermediate batten. Width will be same 400 mm. Depth is now 210. Thickness will be again same 8 millimeters. Then we have D part, forces in battens. Forces in battens. We have VT, that is transverse shear, 2.5% of 1400, which is axial force. Factorial axial force will be 35 kilonewton. Then we have VB. These are given in IS. In IS 800. So I will just tell you the clause number. So just a minute. So we have 7.2.1. So 7.7.2.1. And VB we have, that is resist a shear, and we have this as VTC upon NS. We have VTC upon NS. And now we will substitute the values. So now VT we have 35 into 10 raised to 3. Already we have provided value of C as 1400 divided by N we have 2, and S, that is now this S is distance between the inner boards. So 2 into 50. So S we have, that is S plus 2G. Our S plus 2G. This S is given in IS. If we will see, that is given this distance. So they are going to say, if you will read that clause according to them, that S is this S plus 2G. And then from this we will get this value of VB, and that is equal to 76.5 kilonewtons. Now we can find M, and we have VTC upon 2N, and VT we have 35 into 10 raised to 3. C we have 1400, 2 into 2, and this will give us 12.25 kilonewton meter. Then we have next step, stresses in battens. So E. So we have stresses in battens. This was asked twice in examination. We have tau is equal to VT upon cross section area. VT we have calculated 30, sorry, VB, not VT. So VB we have calculated 76.5 into 10 raised to 3, and battens we have 310, depth multiplied by thickness 8. So we have, this will be my batten now, cross section of the batten. So we have thickness as 8 and depth we have 310. This is what end battens. And we will get this value 30.85 Newton per mm square. Now if we will go to this, I will say tau end battens. If I will find tau intermediate battens, so we have 76.5 into 10 raised to 3 divided by 210 into 8, and we will get this value, that is 76.5 to the power 3 divided by 210 into 8, it comes 45.54. Then we have bending stress sigma, and that is equal to m upon 6m upon Td square. So actually this is m by z, and we have z as b Td square upon 6. This z is I by y, and I we have Td cube by 12, and y is d by 2. And from this we will get Td square by 6. And so we have this value 6. M we have 12.25 into 10 raised to 6. T is 8. D is 310 square. And we will get this value that is equal to 15.93 Newton per mm square. And then for tau intermediate, it becomes, now I will directly go 6 into 12.25 into 10 raised to 6 and divided by 8 into 210 square. And we will get this value 6 into 12.25 to the power 6 divided by 8 divided by 210 square, and it comes 208 point, 6 into 12.25 to the power 6 divided by 8 into 210 square. Yes, 208.33. So I will just calculate this value also. 6 into 12.25 to the power 6 into divided by 310 square, 95.60. So this is also wrong, 95.60. Now we have this value maximum. These are less than FYW upon root 3 gamma MO. Less than FYW upon root 3 gamma MO. You can go clause number 8.4, you will get over there. And this comes, if you calculate this value, it is 131.26. Now this value, this is sigma intermediate. Now this value is less than Fy upon gamma MO, 8.2. And that is 250 upon 1.1. It comes 227 Newton per mm square. So both criteria are satisfied. Now we will go to the next point, which is F. And we have, next step, we have step 3, connections. Now we have VDSB. Single shear we have, I will directly go FUB upon root 3 gamma MB into NS into ASB. And if we will put this value 410 upon root 3 into 1.25, NS is 1 into pi by 4 into 20 square. And we will get this value 58.04 kilonewtons. Then we can go VDPB 2.5 kb dt Fu upon gamma ml. Now kb we have to take 1 because we do not have p and all this. So 2.1 into 20 into 8 Fu we have 410 and divided by gamma ml is 1.25. It comes 131.2 kilonewton. Therefore VDB is 58.04 kilonewtons. And then we have number of bolts equal to force, we have 76.5. This is VB divided by 58.04, and it comes 1.32, but provide 3 bolts because it should accommodate stresses due to bending also. This will give due to shear only. So provide 3 bolts. And now we will go Force in bolt due to shear. Force in bolt due to shear equal to, now we have shear force VB divided by N number of bolts. And then we have this value, that is VB, we have 76.5 divided by 3, and this comes 25.5 kilometers. And then force due to moment. So we have force due to moment, which is equal to mr upon summation r square. So we have this will be 1, 2, and 3 volts. And we will consider this distance as 100. So we have to provide more over there so that our stresses will be accommodated over here. And then MR, that is the distance, we have 12.25 into 10 raised to 6. And R, that is farthest bolt, we have at 100 mm into 100 divided by summation R square. So centroid will be here. So this will be 1 R1, this will be R2. And this is 0. So we have summation R square is R1 square plus R2 square. And we will get it as 2 into, we will get it as equal to 100 square plus 100 square. So if we will go to this, so we have 100 square plus 100 square, and that will be 20,000 x inverse. So I have 100 square plus 100 square. And then we will get it as into 12.25 to the power 6 multiplied by 100. And this comes 61.25 kilonewton. So it is greater than 58. So we have to go more number of bolts. And therefore we will go 4 bolts. 1, 2, 3, 4. And let us we have this will be at center now. So this will be, now I will say this will be, this distance I will increase. So this distance, let us, I will say 140, so that it will be 70. This will be 70. And then we have this as 140. So what will be R square? So we have 2 times 70 square plus 2 times 140 square. Because we have, 140 plus 70. So R1 we have 70 and R2 we have this distance. So R2 is equal to 70 plus 140, and that will be 210. So this value we have plus 2 into 210 square. And then we will get it as 2 into 70 square plus 2 into 210 square. And this comes 98,000. So we have this as 98,000. And then we will get force due to moment. Force due to moment. And that is equal to 12.25 into 10 raised to 6. Now farthest distance we have 210 now divided by 98,000. And then we will get it as x inverse multiply by 210 multiply by 12.25 to the power 6. It comes 26.25 kilonewton. And then we have Fr is equal to root of Fs square due to shear plus Fm square due to bending. And then we have this will be due to shear we have 25.5 square plus due to moment we have 26.25 square. And then we will get it as 25.5 square plus 26.25 square, and root of this we will have 36.6 kilonewtons, and this is less than VDB, which is 58.04 kilometer. So likewise, we have to solve these problems of Battens. So now we will stop here only. Remaining part we will see in next lecture.